For coming today. My name's Don Carr and I'm an industrial designer, and I've designed everything from skis to ATM machines to computers to photocopiers. Pretty much all of them are totally out of step with nature. They just pale in comparison. Over the past 2 years I've had a new role besides being a design educator. I'm also the senior collab fellow down at the warehouse within the design discipline. And so that's the collaborative think tank or work environment within our midst where we try to reach out and find connecting topics that map the design disciplines onto the rest of this university. So when Janine Benyus came here and mentioned David Eltoff and Claire Olson from architecture, biology architecture, ESF, I said, biomimicry, that is amazing. I think we need to do something about that. So in discussions with Ed and Tammy about a year ago, we said, hey, let's have a biomimicry challenge. Let's do it in the Center of Excellence underneath the green roof in the lab wing. Can we do it about 8 weeks from now? And we said, well, yeah, so in essence it was a challenge. Can we pull this off in year one? And that led to discussions with the Stacks, discussions with John Yoder in architecture. We were able to get Stuart Jones, the VP of Sustainability from Interface Carpet, to come. Dr. Marcos Cruz came from London and gave the keynote address. And the key to the biomimicry challenge is learn about biomimicry, try to apply it to the design brief you're faced with, but have that discussion with a biologist at the table. Too many times we don't think about how nature has solved things all around us. We just pick up pad and paper and we start sketching. So this year, we're pleased to say that we have Herman Miller as one of our lead sponsors offering us a challenge. We also, we've got our corporate guests here today. If you would like to sponsor a challenge of these bright students from across our campus, be sure to take one of these, write it down, write your challenge down. And sure enough, March 22nd, you may be on the poster. You may be one of the 3 challenges that we do on this Saturday. So that could be really exciting if we try to solve one of your tough problems. So what we're going to do today is we've got Miriam Pai from NYSERDA, and she's a senior project manager and team leader for manufacturing technology development and biomimicry efforts at NYSERDA. She's going to get us going. She's going to show some great case examples, and she's very much a proponent of showing how we can get some projects going that will really make a difference in this world, and NYSERDA can play a role in that. So I'm glad that she can be here today and start us off. I'm then going to have Matthew May get up, and he's looking at fireflies, and he could be talking about the future of lighting. Everything around us could pale in comparison to the lighting of the future. And I think we'll have David Eltoff introduce him. And then to close it out, the dynamic duo of myself and David Eltoff, we've decided, well, how can we apply biomimicry? How can a biologist and a designer talk about it together? And so we thought we'd talk about disaster relief. We thought we'd talk about situations where there's a flood, whatever the disaster, humans are scattered, they have to reassemble, they have to take care of their basic needs. How do we solve that efficiently and effectively as humans, but how does nature solve that? So that's our closer. So those are the 3 for today. Hopefully you guys will enjoy this. And then we got a nice reception, which the COE is set up for us afterwards. So let's welcome Miriam.
So how many people are familiar with biomimicry? How many people could name 5 examples of biomimicry? Okay, good. Great. So because Don asked me to give an overview, and this is a presentation I've given quite often. I tweak it every time. But I call these appetizers because they're just enough for you to go, oh yeah, that's pretty cool. But I don't dive deep into the science. So biomimicry is basically seeking sustainable solutions by mimicking nature. And the beautiful thing about mimicking nature and about nature itself is that nature has no waste. The garbage that comes from one organism is the feedstock or the food for another organism. And it's only taken nature about 3.8 billion years to do this. It's not that nature is so brilliant. It's that nature has done trial and error. What works and what doesn't work. And what's around today in nature is what works. So it might be a good clue that we would do well by mimicking it. And going to something very basic. Certainly biomimicry, I'm sure the Wright brothers had that in mind when they created an airplane. And this you'll recognize as something you pick off your dogs, cockleburrs. So about 50 some years ago, there was a guy walking his dog in Switzerland, and as he was picking these off, he thought, I think I can do something with this, and Velcro was born. So that was an example of sometimes we see something in nature and we get an idea, but sometimes we have a problem in real life, and we look to nature for the solution. So you're probably familiar with the Japanese bullet train. Well, no, the nose of it looks kind of like a bullet, and when it would go through a tunnel, it would compress the air in the tunnel. And when it would come out of the tunnel, because the density of the air was less outside the tunnel than inside the tunnel, it would make a really big boom, and the neighbors did not like that. So the bullet train folks said to the engineer, fix it. And he was a birder. So he said, well, what in nature can go from one density medium to another seamlessly? Well, it's the kingfisher bird. It can dive into the water, needs to do this so it can see its prey. And look, there's hardly any splash at all when it dives in. And it can do that because it's got that beautiful long beak. So he redesigned the nose of the bullet train to look like the beak. Not only does it not make the boom anymore, but it's 10% faster and 15% more efficient. Now this is an interesting shape that we often see in nature. It's based on the Fibonacci series of numbers, and what Pax Scientific is the company in California. Actually, California lured them there from Canada. They have mimicked this design because they realized that it optimizes the flow of both air and water. So this is an example of one of their water pumps. And they also make fans that are more efficient and quieter based on nature's design. This is a whale fin, and about 25 years ago, Dr. Frank Fish was vacationing. I think it was on Cape Cod. And he was in the gift shop and he saw a statue of a whale that had bumps on the leading edge. Well, that doesn't make any sense. You would expect the leading edge to be smooth, right? To be more streamlined. Well, actually, no. Now, he studied that for 25 years, and he realized that those bumps are actually making the whale fin more streamlined and allows the whale to maneuver very well. So they've applied that to windmill blades, a company called Whale Power Wind Energy, and these blades are more efficient, more resilient, and stronger. These are mussels, and if you've been to the ocean and you've seen the mussels attached to the rocks and the waves crashing along the rocks, well, they're stuck there with a glue. Human beings can't make glue that works underwater very well. We haven't to this point. Columbia Forest Products on the West Coast has created a product called Pure Bond. It mimics the glue that the mussels use to stick to the rocks. It's very strong, holds underwater, and there's no formaldehyde. Does anyone recognize what this is? Termite mound. I've never seen one quite that large before. This is in Africa. And it's not just a lump of sand. This is a cross section. And you can see there are channels within the mound. And termites need to keep their mound within about 1 or 2 degrees. And they do that by opening and closing these channels so they can let cool air come up from the ground if it's too hot, and they can let hot air in from above if it's too cold. And they mimicked this over 10 years ago in Zimbabwe with a commercial building. And they have no traditional HVAC, heating, actually cooling system in the building, so they saved millions of dollars there. And the building uses about 10% of the energy of an average building, so the rents are much more reasonable. But what's interesting here is that Scott Turner from Syracuse University, from SUNY ESF, has found out that it's actually a lot more complicated than this, and the walls act like skin. So he is leading a group of researchers that have $1.4 million to study how the termite mounds are actually like human skin, and hopefully we can apply that to our buildings. Coral reefs. They make a very hard substance using CO2 and calcium at ambient temperatures. It's kind of similar, the end product is kind of similar to our cement. As you probably know, cement companies are a huge emitter of CO2. And Calera Green Cement on the West Coast has figured out a way to mimic how coral makes a hard substance. And instead of being a CO2 emitter, it can actually sequester CO2. They're having a little bit of a problem making this work financially, but this is really, if they can make this work, it would be very, very cool. So we've looked at a lot of different products, but let's think of nature as the whole ecosystem, this beautiful ecosystem where there is no waste. And in this picture, you know, it looks like any other town. It's got a factory, it's got some farmland and some houses, but it's actually a beautiful ecosystem. In the middle of it, you see an electric power station. And one of the nasty emissions is volatile ashes. Well, they use that at a cement factory nearby. The gypsum byproduct they use to make plasterboard. They have steam that gives power for a bioplant, which has byproducts of yeast and sludge that they use at farms, pig farms, egg crops. They heat the houses of the community. They have a waste heat that goes to fish farm, and the fish farm sludge goes to the local farmers to be used. So it's this beautiful ecosystem. And here in New York State, I've realized that there are a lot of universities doing research in biomimicry. And one example is Ron Miles down at SUNY Binghamton. This is the Ormia fly. And he was trying to make a better hearing aid. And the story goes, he went to a cocktail party, and he said, well, what bug in nature has good hearing? Well, it's the Ormia fly. And so he's actually made a better hearing aid based on the fly's hearing. Anil Netravalli at Cornell is mimicking spider webs. And as you probably know, spider webs are, I don't know, 10 times as strong, ounce for ounce, as steel. So that would be an amazing study. So NYSERDA, why is NYSERDA interested in this? Well, 5 years ago, my boss and I came to Syracuse. We heard Janine Benya speak. We were thrilled. We do industrial R&D. We fund research and development. We give grants. But we decided, well, we could learn from nature. So we've been spending money to do outreach, workshops, and consulting, and basically doing matchmaking. Trying to get the academic researchers together with industry to come up with a better product, a better way to do things, and a better way to save energy. So I'll give you the examples of projects that we're funding or have funded. That is photosynthesis. I don't know if anyone recognized it. It's been a long time since I've studied that, but a few years ago, Novomer, which is down in Ithaca, came to us and said, we want to make plastic using CO2. And we're like, what? But that's what plants do. They make their plant material using CO2 and light and water. And they've actually been able to replace as much as half of the petroleum feedstock that is typically used in plastic. Ecovata design. Okay, so these are two guys that graduated from RPI in either 2005 or 2007. They now have a company with 50 people. And they're growing insulation materials, building materials. They use waste from ag crops. So they're actually upcycling these ag byproducts. And there are no toxic adhesives, no petrochemicals, and has a low embodied energy, which is why NYSERDA has been interested in this. So we've funded quite a few projects with these guys. Pliant Energy is down in the Brooklyn Navy Yard, and they are developing hydrokinetic generator, and they're mimicking the knife fish. One of our newer projects is with SUNY Albany, the CNSE, College of Nanoscale Science and Engineering. And we got them together with a company called Air Innovations. And Air Innovations makes heating, ventilation, air quality machinery, apparatus for buildings. And the folks at SUNY Albany have been working on anti-fouling coatings based on nature. And what they're thinking they can do is coat these filters so that instead of using a lot of energy to clean the air, you can actually use a biomimetic coating to clean the air and have better air quality using less energy. RPI is doing, and a lot of people are doing research with photosynthesis and mimicking photosynthesis. So my newest project, the contract was just sent out yesterday, yay, is a reduction oxidation catalyst that's going to speed up the photosynthesis process and make it applicable for renewable energy and storage applications. And we've got them teamed up with a battery company called Bettergy in New York. And this is a project where we got a researcher together with a very small company, Enertiv, and they are looking at insect-inspired algorithms to control heating in buildings. Ants and bees are amazing at talking to each other, and there have been products already produced that help control energy in buildings. And so that's one that is actually, they proposed to NYSERDA, and we're hoping that that gets funded. So this is our start. These are so far our irons in the fire, and what we'll be doing over the next 3 years is continuing to do this matchmaking between industry, academia, venture capitalists, to get the right teams together so that New York State can become a leader in biomimicry. And we're the only state doing this. There are certainly a lot of efforts around the country and around the world, but we're the only state-led effort to try to be a leader in biomimicry. A nod to Janine Benyus, who coined the term biomimicry about 15 years ago, maybe. She's got a great book. She's an amazing speaker. And if you'd like to listen to her, you can go to TED.com. And she started an organization that is now known as Biomimicry 3.8. It used to be the Biomimicry Institute and the Biomimicry Guild. But Biomimicry 3.8 is the leading knowledge center for biomimicry, so you can check out their site. And has anyone been to asknature.org? Okay, this is a very cool site that you can go to and type in just about anything, any sort of problem. How does nature store energy? How does nature make color? And you type that in, and it shows you all the examples in nature that do the things that you're interested in. So it's just a really fun place to go, and a fun place to start if you're trying to solve a problem. So here's where you can find me, mep@nycerta.ny.gov. I've also included our website address here. We have, I mentioned the Biomimicry Innovation Center, and I mentioned our outreach efforts. And the funding that we have for that is basically to do the outreach and the matchmaking. But once we find a match, we send these projects into solicitations that NYCERTA offers. So we have buildings R&D, we have advanced power systems R&D, battery energy storage, advanced manufacturing, and all of these biomimetic projects will be funded. The ones that are chosen will be funded through the programs that you will find here under current funding opportunities. So I think that's all I have for now. Great.